with this next question that I'm posing. Why would you choose aerospace? Aerospace is not for everyone. We'll come back to that. But first, I'll tell you why I have chosen aerospace as my career. First of all, I love the fact that we design, build, and test things that fly. There's more than that. Second, we design vehicles that can go anywhere. And on the next slide, you'll see vehicles that have even gone to Mars are part of the aerospace business. Now, getting into aerospace is not easy. It takes hard work, and you have to be good with math and science. Hiring, as a result, is very selective because there are just a few positions available and many people interested. But it's worth it. We get to work with the latest technologies. In some cases, we're even asked to invent new technology. And once in a while, we get to be part of making history. For instance, the groundbreaking LCA, light combat aircraft, that India developed, and which Moog was a part of. But let's talk about a serious side of the business. Every day, millions of people fly on aircraft, and they've come to trust that the aircraft will indeed make it to their intended destination without problems. And that's the serious side, because we are responsible as aerospace engineers for the safety of the people who fly on the aircraft that we've designed. Sorry, folks, for the little technical difficulty. We'll get this back up in just a second here. There we go. The next slide shows a picture that has been familiar to many of us for years. It's a picture of the space shuttle taking off from the Florida launch pad. This is Space Shuttle Mission 51, STS-51. No one knew that this flight would end in disaster, but it was, in fact, an inevitable surprise with terrible consequences, and it could easily have been prevented. O-ring damage noted as early as the second space shuttle flight, STS-2, was actually a criticality 1 failure which should have grounded the fleet. But because of pressure to maintain schedule, the engineers were asked to run special tests that tested the O-rings that had failed or were burnt at 3 times the pressure, and they made the decision to keep flying. This decision was clearly against the operational guidelines for the program. In the ensuing flights, there were 12 additional instances of failure of the O-ring, of burning of the O-rings. None failed, but they were burned, damaged, and it was a question again, should they fly? Each time, the engineers determined that it hadn't failed yet, it must be safe. And unfortunately, on Space Shuttle Flight 51, the O-ring did eventually fail. And you can see on the next slide that the solid rocket booster wall burned through and ultimately led to the complete failure of the mission. After the failure, the entire crew was lost, and the 2 solid rocket boosters continued to fly while the shuttle wreckage plummeted to Earth. Now you may wonder why I bring up such a serious and sobering topic in the middle of a conversation about aerospace careers, and it's this. Engineers in aerospace are sometimes called upon to make difficult decisions, and it's very important that anyone considering aerospace as a career should prepare to make difficult decisions. Ultimately, because of poor decisions on the space shuttle program, there were tragic results, and the lives of hundreds of people were changed forever. Friends and family of crew members will never be the same. So as you consider an aerospace career, you'll need to understand that it can be very demanding. In aerospace, lives are at stake, and we take every precaution to make sure our products are as safe as possible. 90% right is not good enough, and that's why engineers are so important to this business. It's our job to design, build, and test products so that they're safe, and at the same time to provide highest performance, the lightest weight, and the best cost that we can. So let's talk about what you might do as a mechanical engineer.